Hello everybody, welcome to this first session of the qualification webinar. Thank you for joining us today. We will address the question how to evaluate and track the performance of your liquid handling processes. So my name is Valentin Bechio. I will be the moderator of this webinar, and I will be with my colleague, Mr. Alexandre Perret, who will be the speaker for this session. Today is the first time for both of us, which makes us very happy, and we hope you will enjoy it too. But first, let me share with you a quick agenda for this 1-hour webinar. So first we'll go over a short introduction of Discngine, the application called qualification and its concepts. Then we will describe you the use case we chose to illustrate today's problematic. After, Alex will perform a live demo of the application, and we should have time at the end of the presentation for 10 to 15 minutes question session. So first, let me introduce you to the tool we use to perform this webinar. It's called GoToWebinar, and you should see a control panel on your screen looking like this. And the part where you can ask your questions is this section. It's called the question section, sorry. So then I will give the screen to Alex, who will start the presentation.
Thank you, Valentin. Hello, everyone. I'm very happy to be here presenting you this new solution that we have. First, I would like to start by talking a little bit about Discngine, because I don't know if all of you have heard of us already, but we are a 14-year-old company based in Paris, in France. We are now 46 employees, but still growing. And Discngine actually provides services and solutions for life science research informatics, mainly in the early drug discovery process. So you may see on the slide a non-exhaustive list of customers. So as you can see, we work with big pharmaceutical company, but also mid-sized biotech and CROs and a few academics. So now let's get started by talking a bit about this new application called qualification. I don't know about you, but when I was in the lab, one of the recurrent question that I asked myself was, how can I be sure that my pipetting operation is doing the right thing? So the question is, isn't it frustrating when the volume dispensed is not the one you expected? And I'm sure that this question pops a lot in the lab, and this is why we have developed Discngine Qualification to answer this specific question. So with Discngine Qualification, what we want to achieve is to help scientists track the performance of their liquid handling processes, and then be able to easily identify some drifts in their process. So the application is here also to answer the question, are your liquid handling process robust over time? But it's also here to answer a lot of other questions, because let's say that I'm a scientist and I'm working in a company. Obviously, these days we are all working in a green company. Yeah, basic. And in our lab, in my lab, I have many devices, balances, liquid handlers, readers, absorbance readers, fluorescence readers, and many devices, and the output files really that they never look the same. So I'm struggled with the different outputs, and I would like to gather, well, I would like an easy way to gather all the information and combine all this information and mostly share the information with my colleagues and my partners and my customers. So all of these questions, you will see that they are answered by qualification. Now let's talk a bit about the concepts of the application. So in Discngine Qualification, there are 3 levels of information. The first one is the platform process. So this is a concept that is defined by 3 things: by the platform, the pipetting head, and the process. So the platform will be the liquid handler, the pipetting head, well, obviously, the pipetting, the format of the pipetting head and its name, its serial number, and the process, for example, a 384 replication or any other liquid handling process that you want to run. And you will name your platform process. And once you name it, you will add information to it to create a second level of information called qualification. In the application, the qualification is actually the experiment that you run on your bench. So what you're going to do is really to take everything that you're doing on the bench and transpose it into the application. So you have this platform process that you just defined, and then you will add information about the volume distribution. How much volume will I dispense in my plate? Is it a single volume, or are there different volumes in my plates? How many plates will I use? What is the plate format? What is the solvent use? You can define the liquid class, the colorimetry reagent, everything, really everything that you're using in a classic experiment or in a classic assay. Well, you can transpose it into the application, and the sum of all this information will be the qualification. It's actually your experiment. And once you've created your qualification, you will add information coming from gravimetry and or colorimetry analysis. So if I take an example and I fill the box that I just presented to you, well, my platform is the CyBio Felix. Pipetting head is a CyBio Felix head. I'm gonna do a 96 plate dispensing operation, and I call this particular platform process CyBio Felix performance test. I will do I will use 12 96 well plates with water as a solvent, and I will dispense 4 different volumes and use both gravimetry and colorimetry information for my analysis. So if I'm a bit more schematic, the use case that I will use in the demo will look like this. We will start with 12 empty plates. The plates will be weighted in with a balance, well, let's say the Moduloplate. So you will have an empty weight for each plate. Then you will fill the plate with the CyBio Felix. So 4 different volumes dispense here, 5, 10, 25, and 50 microliters. Then the plates are again weighted to get a gross weight per plate, and they will be read by an absorbance reader, for instance, in this use case, the BioTek reader. Note that we will have different file outputs, and we will combine them in the application and use them in Discngine Qualification. So now it's time for the live demo, and I'm going to switch to my application. So here is the home page of the application. So the application is a web-based application, so it's accessible via a single URL address. So basically, you can access it with any devices connected to internet. So you have several sections to manage your team, to manage the events that are happening on your robotic platforms, on your pipetting head. Well, I'm not gonna go through all those sections because I really want to focus on this specific use case. So I'm directly going to create an analysis. So here is the homepage of the analysis section. And you can see that there are 4 different analyses already created. So that's my history, because I've run in the past 2 months, 3 months, well, several analyses, and I gather all the information here. And now I'm just going to create a new analysis, sorry, to add more information to my qualification. So first, as a scientist, I want to use my specific qualification. So that's my experiment. I can have information about my experiment. So here, this is the name of my platform process with the target plate formats, the name of the platform, the process I'm going to do, the pipetting head use, all the information actually about the pipetting head, the name of the qualification, and every information about the qualification materials that I think are relevant to my experiment. So the number of plates, the default reader, etc. So you have here information about your qualification. I'm going to name my my analysis and choose to work with both gravimetry and colorimetry data. The essay date that you have here can be modified because you may create the analysis in the application just today, but the related essay, you may have done it a few days before, so a few days ago. What's not going to change is the creation date for the analysis in the application. So I'm going to the next step, and the next step is all about gravimetry. So you can see here that I have 2 empty columns corresponding to the empty weight and the gross weight for each of my plates. I have my 12 plate indexes here. And when I created my qualification, I've already set the control layouts and the volume layouts that I'm going to use in this analysis. To have more information about my layouts, I can just pick it in the list here and see how it looks. So in my case, my plates are filled with compounds for each one. If somehow I don't have the right layout, I can still create it on the fly by clicking on the plus button. So now I want to fill my gravimetry information added to the form. So I have several ways to do it. The first one is to manually enter information for each plate, which can be really painful if you have a lot of plates to work with. So let's say, for example, 12 plates. I don't want to do this. So I can load data automatically, either by copying and pasting data or by uploading a file. So in our case, we're going to copy and paste information. So let's go to the data. Okay, so I'm opening the gravimetry data file. This is here. I'm selecting everything and then pasting it into the application. So here I have the information about my gravimetry data. So I'm just going to make sure that I have headers in the file to keep the box checked, and then go to the next step, which is a mapping step. And here I just need to make sure that the columns in my file are well mapped with the columns in the application. So everything is okay here. I just need to map this column with the volume layout and go to the next step where I can check if everything went well. And I have 12 rows, well, corresponding to my 12 plates. So everything's okay. I can load the data. So you can see here on the left, I got my information about empty and gross weights per plate. But when I load the data, I also updated the well target volumes. So now it's basically consistent with my use case. So 4 different volumes, 3 plates per volume, and I have information about the well measured volume per plate. Obviously, this is an average measured volume here. And I have information about the volume bias and the well volume relative bias. When I set my qualification, I also set some limits. And in my case, I didn't want to have a relative bias above 5%, which means that here my plates are highlighted because the relative error is above 5%. So it's just information about the behavior of my pipping operation first. It's a gravimetry information. So I'm still going to take it under consideration, but since I'm working with colorimetry data, I want to make sure that my pipping operation is okay for each well in my plates. So I'm going to the next step to load colorimetry data. So here everything was already set up when I created the qualification. So I just need to upload my files. So see, we have different file format, and here I can select all at once my 12 files corresponding to my 12 plates and upload all the files at the same time. Then I'm going to a checking step when I want to make sure that my colorimetry information were well read by the application. Do I have any missing information? No, everything went well. So I can go to the next step. And in Discngine Qualification, I can actually convert my optical densities values to volumes. I can do this in several ways. The first one is just to manually enter conversion factors to specific volumes, factors that can come up from methods that are described in the Iowa 15 standards, for example. But I can also apply some conversion procedure, such as linear regression procedure or second order polynomial regression. So the only thing I need to do is select the procedure and enter the parameter of my regression. Today, you will need to enter manually those parameters into the application. But tomorrow, meaning in the next few days, few weeks, I will be able to upload directly my reference plate used to calculate my regression parameters, to convert my optical densities to volumes, and I can upload it directly into the application. So I won't need to do this outside of the application, but tomorrow I will be able to directly upload the raw data file for my reference plate and get directly regression parameters. In my use case today, I'm going to use conversion factors for each volume. So I can manually enter them. So it's going to be pretty quick. All right. Okay. So I apply my factors. Okay, and I'm going to the next step, which actually is the heart of the application. This is where you can combine all the information and you can have a look at your data from different perspective. So first, you're going to this validation step, and you have a plate viewer, and you can actually switch from plate to plate. But I want to remind you that I'm in an optical density range of values, but I converted my optical density to volume. So I can decide to switch from optical densities to volumes, and then I have the information here, and I can go plate by plate to check if everything is okay. And I can, for example, notice that, well, when I filled my plates during the pipetting operation, I may have noticed that I have an air bubble for a specific well. So here, if I know that the air bubble was located in the C9 well, I can select my well and actually invalidate it. So I'm going to invalidate the well. So the reason for the invalidation can be managed from the administration section of the administration. And also, I know that for some, well, in some companies or in some lab team, the invalidation procedure is not used. So the administrator of the team can choose to hide the possibility to invalidate wells. So I just invalidated one well. It's here, but so by selecting a well in my plate, but I can also use the z-score distribution, which is a statistical parameters that gives me information about the dispersion of my values. So I can actually select a certain number of values depending on the criteria, a numerical criteria that I want to that I want to use, and then it's automatically selected the wells, and I can invalidate them as well. Well, I'm not going to do this. I invalidated one well already, so it's okay. You can also filter here because we are working so far on a 5 microliter target volumes, but I can filter my plates. Let's say use the 9th plate. And the 9th plate, obviously, I'm not going to see anything because the target volume is 5 microliter. So for the plate number 9, I think the target volume was 25. So I can have my informations also by filtering options, by filtering over the target volumes or the plates. What could be also nice to see is not only the volume values for each well, but also the relative error. And I can choose to display the volume relative bias per well in percentage. So I can see here that for the well B1, well, I have an error of 3%. And this is actually my largest error, which is, well, in my opinion, which is fine by me. So I'm not going to do anything about this plate, but I can go check all my plates to see if I have huge errors. So this is one way to look at your data. But you have several ways actually to validate your data and to check your data. You have these two tabs here, column and rows and plate statistics. And when you go to the columns and rows tab, you have information about the volume average per column and the CV per column. But it's always an average value filtered by target volume because we don't want to have an average value over different volumes. It wouldn't make any sense. So here you have the information about which plates are involved in the same volumes. So you have information here about your average volume, about the CV. So this CV here is a bit erratic, but still it's lower than 1.5%. So it's quite nice. And I can check this for each target volume. I can also go to the plate statistics tab, where I have the information about the volume average and the CV per plate. So we are always working in a specific target volume, but in this target volume of 25 microliter, I have plate 7, 8, and 9 involved, and then I have the information about the volume average and the CV for each plate. What I can also use in the application is several different visualization. So I can see my data from different standpoints. And for example, I can check the CV row by row, plate by plate. And I can notice if somehow I have a column or a specific row that is really out of range, well, out of my range, because for me, my limit is 5% for the CV. And for the 25 microliters, it's actually pretty good. So I can go see the smaller volumes, which I know are a little bit trickier. And I can go check for the CV for my rows and my columns. And I can see, for example, here that I have several columns where the CV is above 5%. So I can also here select the columns or the rows and invalidate them if I have the possibility to do it. So just to say that when I use qualification, I actually have different options to look at the data, and it's just up to me, scientist, to use well, one or several particular visualizations and use them to validate my data. So now let's go to the next step, which is a summary information. Okay, this is always the demo effect. So I think it's okay. Yep. And in this page, I have information about the status of my data. So I can go from plate by plate and see, starting by the gravimetry data, if my plate is in the acceptance, in the tolerance range that I've set up when creating the qualification. This range can be changed by using the button define cutoff, so I can lower the range if I want to do so. So here for the gravimetry part, the range is all about the volume relative bias, meaning that it's about the accuracy. And for the colorimetry part here, you have information about accuracy with the column volume relative bias and the precision with the CV column here. And my status here deals with CVs, and in my tolerance range is actually 5% for the CV. So I can check if my plates present a CV above 5%, but I see that I have only the first plate here where I have a CV above 5%. So now that I've created my analysis, I've combined all the information I wanted to work with. I can now publish my data, and publishing the data in Discngine Qualification means that I'm going to add the data to a history. So if there is no history yet, I'm going to create a history. So let's publish the data and go to the details of the qualification. So the qualification is my experiment, and actually here I can see that I've done in the past 4 other different analyses, and I just add data. So my fifth analysis that I've just done. I did it today, just right now. Well, all the informations are here, and I can track the CV and the volume average of my pipetting operation over time, and I can see the behavior of my pipetting operation, and I can also identify patterns if I have wrong patterns. So, for example, my fourth analysis here, the CV from the gravimetry were not that good, but I can see here that the behavior is okay. So it maybe was just one specific mistake because there was some air bubble. So because it was just before a preventive maintenance or after a preventive maintenance, because I know that well, let's say sometimes usually after the preventive maintenance, you just need to recalibrate everything. And well, you can have information about where the data is coming from. So this is the name of the analysis is analysis 4, and it was done on October 17th, etc. So this is information about my CV, but I also have information about the volume average here. So volume average from the gravimetry data and from the colorimetry data. So it can be a little tricky to see information here. That's why we can filter by volume. And I can choose to work on the smaller volume, 5 microliter, and look at the behavior of my dispensing operation for the 5 microliter volume. So if I go to the volume average, for example, well, I can see that all my volumes, well, the average actually, it's well below, sorry, my target volume. But in the meantime, I have, let's say, reasonable CV. So that means that in my case, the precision of the operation is good. The precision of the process is good, but the accuracy is not that good. So it's just information that we give to the scientist. So here I have the information about my data, and I can use this information to take decision. Let's say, for example, that I identify a pattern that's for the 5 microliter. Every time my CV is off the chart. So, well, when I say every time, it's you've done it 3 times, well, 2 or 3 times, and it's always off the chart. So you can wonder, maybe I need to give a call to the preventive maintenance guy, and he's gonna come to my lab and check if everything is okay. So basically, this is all I wanted to show you today. So what I could do with Discngine Qualification is actually I could combine colorimetry and gravimetry data, and I could also track the performance of my liquid handling processes. So here are a small summary of what I've done. So I've tracked the precision and accuracy of my liquid handling process. I've tracked it because I created a history from previous analysis. So I kept all the information together, and I could actually have information about the behavior of my process, of my pipetting head. Well, like I said, combining gravimetry and colorimetry data. So most of all, I could also monitor my my qualification history, and I can validate my robotic processes in real operating conditions. So what I mean in real operating condition is that you actually took well, what I've done is I actually take everything that I had on the bench and I just transpose it into the application. So no differences here. No difference. Everything I've done in the bench, it was used into the application. And the good thing also is that I can easily share my analysis or my qualification history with my customers, my partners, my colleagues, because we are working in a team. And in the application, in the team, my project manager or my team administrator can invite a customer or a partner for them just to have a look at the performance of the liquid handling process. So and have a look at the job that we do. So if you want to try the application, we would be really happy to talk about your use case and to set up an account for you and just for you to try the application. So really, don't hesitate to contact us. And now I give the hand to Valentin. Thanks everyone for your attention.
Okay, thank you, Alex, for this great presentation. So now, as you can see, it's time for the question session. So remember, you can ask us your question thanks to the GoToWebinar panel in the questions section. But first, to start it, we have a question for you. So I just launching a small question you should probably see now in your screen. So the question is, which subject would you like to see for the next webinar of Discngine Qualification? So you can now answer. I see that we have a few answers coming. That's good. Yes, you can keep voting. Great. Yes. I'm just keeping it open a few seconds. All right. Yeah, there's still a few votes coming in. Okay, maybe I will wait, let's say 10 more seconds. Okay, I think, yeah, so we had the majority of people answered, so it's good. Thank you very much. I will now close, sorry, the poll and the small questions. So, okay, the first question for you, Alex, is there any limitation regarding volume ranges?
So actually, no, there is no limitation regarding volume ranges because the application is only working with numerical data. So we can use volume from nanoliters to well, up to whatever volume range you're using. So for example, in the application, we have a use case about the lab site echo. So you can definitely qualify your dispensing operations coming from the an acoustic dispenser in the application.
Okay, thank you. So we have another question. This is, can the acceptance criteria be locked down and protected with the user management?
Let's say that actually today the acceptance criteria can be updated by every operator. So everyone that will use that will create analysis will be able today to change the acceptance criteria. But we had several feedback about it, and this is definitely something that we want to address, meaning having the acceptance criteria only edited by the project manager or the administrator.
Okay, great. Thank you for this answer. So the next question, it's do you have already the ability to import data from Tcon readers?
Well, we have a long list of readers in the application, and I don't think Tcon is one of them, just because we don't have a use case so far. But it's quite easy for us to just create a new reader. So the only thing we need is an example, is a raw data file, and we definitely know how to do it in a couple of hours. We can create a new reader. So so if the person that asked the question wants to send us some raw data example files, that would be very nice, and we can create the reader right after that.
Okay, thank you. So we have the next question. It's can I use the fluorescence instead of colorimetry?
Sure, absolutely. It's actually related to the little bit related to the question before. The only thing we need is an example data file, and we will make sure that you can read properly the file, your raw data in the application. But since you are actually transposing everything that you're doing in the bench into the application, it can be a fluorescence analysis instead of a colorimetry analysis. So it really doesn't matter. We can work with both use cases.
Okay, thank you, Alex. Very good answer, I think. The next question is, can I have different cutoff limits? For example, one for each volume.
Well, that's a very good question, and actually, it's a question that we have very, very often. So far, we can't. It's not available yet. But this is definitely something that we are currently working on, and it will be available in the next release. Yeah, to be able to have a different cutoff limit for each volume.
Okay, thank you. Perfect. So still continuing with question, the next one is, what is the maximum number of users per license?
Well, we actually don't work with a license because Discngine Qualification is based on the subscription model, meaning that the only thing that matters is the number of published analyses. So you can have as many users as you want. It's not limited in time, but what is limited is the number of published analyses. Well, you have a certain number of tokens, and then every time you will publish an analysis, the number of tokens will decrease. And just want to add that the publishing an analysis does not depend on the number of plates or the number of different volumes in the analysis. So in my use case today, I've used 12 plates, but at the end, when I published my analysis, it only took one token.
Okay, thank you very much, Alex, for those answers. So we answered all the questions we received today. If you have maybe a question coming tonight or tomorrow, feel free to contacting us by email. If you want, you have the address on the screen. It's qualification@discngine.com. Or if you want more information, or you can also contact us through the website at qualification.discengine.com. We will be happy to answer you. So I think it's okay for today. We had a great time with you. We hope you had a great time too. This webinar had been recorded, so you will receive a link to the video in an email tomorrow, probably. And we hope you'll enjoy it. Thank you, everybody. Thank you, Alex.
Thank you, everyone.
And see you into the next session. All right, bye.
Bye bye. Have a nice day.